Here we gonna see about cooperative game theory techniques of intrusion detection in mobile ad hoc networks. It was done by Chandrasekhar and Jagannath, uh, guided by Ganesh Kumar, Assistant Professor, Department of CAC. Uh, our main objective is the aim of this project is to save the energy of the node by reduce the duration of active time of the intrusion system without compromising of their effectiveness. Usually, an IDS has to run all the time on every node to oversee the network behavior. Abstract. Uh, Mobile ad hoc networks are self-configuring infrastructure left dynamic wireless networks in which the nodes or resource constraints intrusion resistance systems are used in manner to monitor activities to detect any intrusion in the otherwise vulnerable network. To validate our proposed approach, we model the interaction between ideas, a multiplayer cooperative game in which the players has partially cooperative and partially conflict goals. Um, Now we are gonna see about the existing systems. In existing system, LDK methodology is used to identify the best route. That means once the source node starts transmission, it estimates the nearest node and start transmitting data via the respective neighboring node. V2V communication technologies to reduce traffic collisions, and then the processing raw data and periodically broadcasting to its neighboring node, classifying normal or abnormal based on processed data from its host node and neighboring nodes. The main disadvantages in this project is the energy of each node would be reduced frequently. Network security is not provided. Then these are all the literature survey of this project. Now we're gonna see about the proposed systems. The proposed system, additional layer of security is projected, optimizing network topology for edge self-monitoring in sensor networks with the objective of maximizing the lifetime of the network. Multiplayer cooperative game that analyzes the effect of individual intrusion system with reduced activity on the network. The main objectives of this project is reduce the IDS active time as much as possible without compromising on their effectiveness, maximize the lifetime of the network, reduce the power consumption. These are all the experimental results. Here we compare existing systems and proposed systems. These 5 points are the main objectives in which existing system is changed on the proposed systems. We're gonna see the energy of each node reduced frequently, energy of each node is maintained, power consumption is high, power consumption is reduced, network security is not provided, network security is provided, lifetime of network is maximum, optimizing lifetime network. This is a system architecture. Here we go see node A, node B, and node C. Three nodes. Each node has its minimum degree probability, uh, and then first node A gives a degree request to the node B, and reply degree is sent to a node A, and these things are transferred between three nodes. Then these are the system requirements, the algorithms. We're gonna use three algorithms: RSA, HMAC, two algorithms: RSA algorithm, HMAC algorithm. RSA algorithm is used asymmetric cryptographic algorithm. Asymmetric actually means that it works on the two different keys, public key and private key. As the name describes, the public key is given to everyone and private key is kept private. HMAC HMAC means sometimes de-abbreviated as key hashed hash message authentication code or hash based message authentication code. In a specific time of message authentication code involving a cryptographic hash function such as secret cryptographic key, it may be used to simultaneously verify both the data integrity and authentication of the message. Next is there are four modules: network formation, calculate minimum degree and probability, generating log form monitoring, data communication. In the module network formation, we're gonna do node would be created with finite distance and range, that is the coverage of a particular node. Each node in the network would consist of a unique name, port number for data forwarding, and an idea system to monitor it. Need to take the next nearest node and forward the data to the particular and reach the destination. Screenshots of creating the nodes. We given the distance and the range. Calculate minimum degree and probability. Each node in the network would consist of an IDS that would be used to monitor the node for all time to maintain objective to reduce the time of the individual IDS. We have find the probability and minimum degree, generating log form monitoring. In this node calculate the minimum degree and probability for the node that the node will monitor another node by same time duration. Yeah, we given the logs for each nodes. Next, data communication. In data communication, node can send data or information to other node. If the destination node and the coverage of the source node, then it can send the data directly. Node encrypt the data for privacy purpose and sign the encrypt content to verify that the content is not changed by anyone. The screenshots for data communications. We select one text. The text is sent to the node 1. Then these are the public key message this destination received from the node N0111. Log for monitoring. Long authentication failed. These are all the reference papers. Thank you.